Okay, so these will be problems 6 through 15, backside of the second page. Determine whether the sequence is arithmetic. If the sequence is arithmetic, write the recursive and explicit formula to represent it. Okay, use your 3x5 card in this section to write these two formulas. I'm going to write the explicit formula quickly here. A of n equals starting number plus n minus 1 times the difference. Okay, so in this situation, I'm going to fill in my starting number. A of n equals, starting number is -5, plus n minus 1 times the difference. And here I can see that it is adding 3 from each term, so times 3. Now I want to write the recursive formula. I wrote on the back side. A of 1 equals the starting number, -5. First term is the starting number. So the current term equals the term before it, plus the difference, and the difference here is 3, so plus 3. So these are my two formulas. Number 7. I'm going to write the explicit again. Equals the starting number, it's 20. And comma A of n equals A of n minus 1. Okay, fill this in. Go -20, -18, -16. Fill in those negatives. Those negatives are missing. So I could see that it is increasing by 2. Now remember, this is a larger negative. The closer we get to 0, we are actually increasing. So this is plus 2, and that would be a -20 as my starting number. This is the recursive. I think I said that's the explicit. I apologize. This is A of 1. Got a little distracted. That is the recursive formula. Now we're going to write the explicit. Equals the starting number, -20, plus n minus 1 times the difference, which is 2. Okay, find the range for the function in the given domain. So what that means is these are our x values that we're going to plug in, and our outputs, these are inputs, will be the range. So f of -4 equals -3 times -4 plus 2. So f of -4 is equal to -3 times -4 is 12 plus 2. 12 plus 2 is 14. So here's one range. So my range is going to be a set of numbers. The first one is 14. Let's find the next one. Let's plug in 2. F of 2 is equal to -3 times 2 plus 2. Again, just plugging in my inputs, getting an output. That is the purpose of a function. -6 plus 2. -6 plus 2 is -4, so f of 2 is -4. That is the next number in my range. Now let's plug in 5. So f of 5 equals -3 times 5 plus 2. That's -15. -15 plus 2. And so I'm going to find that f of 5 is equal to -13. So that is my range. Same thing for number 9. I'm going to plug these in. These are my x values. This is my domain. My answers will be the range. So f of -2, I get -2 squared minus 4. -2 squared is 4. So f of -2, 4 minus 4 is 0. So in this case, the first number in my set is 0. I'm going to plug in 0. F of 0 equals 0 squared minus 4. 0 squared is 0, so I get 0 minus 4. 0 minus 4 is -4. The next number in my set is -4. We're going to plug in 3. f of 3 equals 3 squared minus 4. 3 squared is 9, 9 minus 4. So f of 3 equals 5. Okay, state whether the relationship should be represented by a continuous or discrete graph. So John's height over time. John is continuously growing, even though it might be really hard to notice the amount that he is growing. This is a continuous graph. The price of maple bars. Well, you can't buy a half of a maple bar. You have to buy it by the whole bar. So this is a discrete situation. You buy it by the bar. Okay, state whether the set of ordered pairs x, y represents a function of x. So we're looking for the x values to repeat. If they do repeat, we want to see if the y value is different. So in number 12, look at my x values. None of these x values repeat, so this is a function. So let's write function. Okay, I'm going to look at number 13. None of my x values repeat. This is a function. I'm looking at number 14. Now I do have two x values that repeat, so I need to check. Are the y values different? Yes, these are different. If I graphed these 2 points, they are stacked over each other, which means it will not pass a vertical line test, so this is not a function. Okay, make a table of 3 values for the function rule, then graph the function. Alright, now you can see that when I make my table, I want to make sure that I'm using numbers that are a multiple of the denominator. So these are all a multiple of 3, except for the 0. We can always use 0. Okay, so if I plug negative 3 in, I get negative 4 over 3 times 3 minus 3. Okay, 4 times 3 is 12, so I get negative 12 over 3 minus 3. 12 divided by 3 is negative 4. Minus 3, it's negative 7. So let's graph this point, negative 3, negative 7. And 1, 2, 3. There it is. Okay. Let's plug in 0. Negative 4 over 3 times 0. Should have put the parentheses there. Minus 3. 4 over 3 times 0 is 0. So I get 0 minus 3, which is negative 3. So 0, negative 3. Now let's plug in 3. Negative 4 over 3 times 3 minus 3. 4 over 3 is and I made a mistake on the first one. Awesome. 4 over 3, 4 times 3 is 12. So I get negative 12 over 3 minus 3. Negative 12 divided by 3 is negative 4. Minus 3, this is negative 7. That's this point. So I made a mistake on this one and I dropped my negative. I apologize for that. This should have been a negative 3. Negative 3 times negative 4 would come out to a positive 12 over 3. Positive 4 minus 3, which would just be 1. Negative 3, 1. That would be this point, and this should be a positive 3 down 7. Apologize for that mistake. Here is my graphed line. Okay, next video.